Okay, this is Unit 7, Topic 1, Homework, Part 3. So number 17 here, find the cosecant of theta if the tangent of theta is equal to 2 over 3. So first thing I'm going to do is I'm going to draw a triangle right here, and I'm just going to say that my theta is right there. Okay, well, tangent is opposite over adjacent. So opposite would be here, gives me that side of 2. Adjacent would be here, gives me that side of 3. Okay, but now I want to find the cosecant. Well, cosecant is just the reciprocal of sine. So I want to find sine of theta first, and then just flip it. So here, I'm going to use Pythagorean Theorem to find my hypotenuse. So I have 2 squared plus 3 squared is equal to, we'll just call it x squared. Okay, this becomes 4 plus 9, which is equal to x squared. This gives me 13 is equal to x squared. Square root both sides, so we get the square root of 13 is equal to x. So this is the square root of 13. Okay, well the sine of this triangle, according to this theta here, opposite to over the square root of 13. And well, cosecant is just a reciprocal of that. So the cosecant of theta is equal to the square root of 13 over 2. So, done. Okay, number 18. We want to find the cotangent of theta if the secant of theta is equal to 17 over 8. So let's start by drawing a triangle. Okay, we'll say this is our theta again. Well, secant is the reciprocal of cosine. So we know the cosine of theta is equal to 8 over 17. This is adjacent over hypotenuse. Okay, well, adjacent is here. My hypotenuse is here. Okay, but I need to find the cotangent. Before I find the cotangent, I'm going to find the tangent, because cotangent is just the reciprocal of tangent. Okay, so I need to find this opposite side first here. So I'm going to use Pythagorean Theorem. We'll just call this x. So we have x squared plus 8 squared is equal to 17 squared. So now I want to solve for x here. Let's do 4. So we get x squared is equal to 225. Square root both sides, we get x is equal to 15. Okay, so we get this is equal to 15 right here. So now I can find my tangent. My tangent is opposite over adjacent, so it's equal to 15 over 8. Well, my cotangent is just the reciprocal of that. Cotangent of theta is equal to 8 over 15. There's my answer. Okay, so number 19. A nursery plants a new tree and attaches a guide wire to help support the tree while the roots take hold. An 8-foot wire is attached to the tree to stake it to the ground. From the stake in the ground, the angle of elevation of the connection with the tree is 42 degrees. Find to the nearest tenth of a foot the height of the connection point of the tree. So let's draw a picture. So say this is my tree. Okay, there's my tree. Well, then there's a stake out here somewhere. Attached to it is a wire. Okay. We know it's 8 feet. Okay, and the angle of elevation is 42 degrees. Okay, and we want to find the height of the connection point on the tree. So we want to find this right here. This section right here. So let's use trig here. So using this angle, this is my opposite side. This is my hypotenuse. Well, which trig ratio uses opposite and hypotenuse? Our sine. So we're going to have sine of 42 degrees is equal to x over 8. Okay, we'll solve for x here. I'm going to multiply by 8. So now I have 8 times the sine of 42 is equal to x. I'm going to plug that into my calculator. So I have 8 times the sine of 42, which gives me 5.4 feet is equal to x. There's my answer for that one. Okay, so moving on. Number 20. Okay, so here we have Romeo standing on the ground looking up at Juliet at a 67-degree angle of elevation. If he is 40 feet from the base of the building and he is 6 feet tall, how high will Romeo have to climb to reach Juliet if he scaled the side of the tower? Okay, let's draw a picture. So here is my tower. Here's Juliet. Right there. Okay. Well, Romeo is 40 feet away. So 40 feet away, let's just say here. But his eye level, he's 6 feet tall. So Romeo is going to be right there. Looking up. Okay. Well, we know this section is 6 feet. Because he's 6 feet tall. Looking up. Like that. And the angle of elevation is 67 degrees. And he's standing 40 feet away. Okay. So we want to first find this section here. And then add 6 feet to it to see how high the tower is that he has to get up. Okay, so here we have the opposite and the adjacent. So the trig ratio that uses opposite and adjacent is tangent. So we're going to have tangent of 67 is equal to x over 40. Okay, I want to get x by itself, so I'm going to multiply by 40. Multiply by 40. So now I get 40 times the tangent of 67 is equal to x. We'll plug that into our calculator. Okay. We get 94.23 is equal to x, but to find the whole height, we need to add 6 feet to that. So we're going to add 6 feet plus 6. So we get 100.23 feet. All right, there's that one. Next one, number 21. So it says a 20-foot ladder leans against a building and makes an angle of 72 degrees with the ground. Find the distance between the foot of the ladder and the building. Okay, let's draw a picture. Let's just say this is our building. Okay, 20-foot ladder, so there's our ladder here. Okay, we know this is 20 feet. The angle that it makes with the ground is 72 degrees. And we want to find the distance between the foot of the ladder and the building. So we want to find this distance right here. Okay, well, if our angle is here, this is adjacent. This is our hypotenuse. So that's our so cosine. So we're going to have cosine of 72 degrees is equal to adjacent x over the hypotenuse of 20. Okay, well, now I want to solve for x. So I'm going to multiply by 20. So I'm going to have 20 times cosine of 72 is equal to x. Plug that into our calculators. We get 6.2 feet. So That is that distance right there. Okay, next one, number 22. Okay, so it says Banjo lets out 100 feet of string on a kite from a hand height of 3 feet. The angle between horizontal hand height and the kite is 25 degrees. Find the height of the kite above the ground to the nearest foot. Okay, so let's draw a picture. Okay, so let's just say this is the hand height right here. We can say that's his hand. Okay, well the angle made from this is 25 degrees. So we'll say right here, this is 25 degrees. Okay. And his kite is attached to this. Okay, well this is 100 feet he let out. Okay, and we want to find the distance the kite is above from the ground. Okay. Well, this is 3 feet high right here, his hand height. Okay, so here's our ground. So from here, we're going to use this triangle and then add 3 feet to find the distance. Okay, so let's find this first, and then we'll just add that 3 feet. Okay, well this is opposite and hypotenuse, so that's going to be sine. So we're going to have the sine of 25 is equal to x over 100. Solve for x, I'm going to multiply by 100. So I have 100 times the sine of 25 is equal to x. Plug that into our calculators. Okay, we get x is equal to 42.3. Then we're going to add 3 feet to that to find the total distance. So we get 45.3 feet from the ground.